spiral galaxies. They are among the most recognizable structures in the universe. Flat, rotating disks of stars, gas, and dust, with curved arms winding outward from a dense central bulge. Those arms are not fixed like spokes on a wheel. They are wave-like regions where material piles up, triggering the birth of new stars. The bright blue clusters scattered along them are young, massive stars, freshly formed and burning fast. The Andromeda galaxy, our nearest large neighbor at roughly 2.5 million light-years away, is a spiral. So is the Triangulum galaxy. Spiral galaxies tend to be actively star-forming, rich in gas and dust, and are most commonly found in less crowded regions of the universe. In the field or in small galaxy groups where their delicate disks can survive without being torn apart. Barred spiral galaxies. These are spirals with one key difference. Instead of arms emerging directly from a round central hub, they extend from the ends of a straight bar of stars that cuts through the galactic center. That bar is not a static feature. It forms through gravitational instabilities in the disk, channeling gas inward toward the nucleus and feeding star formation near the core. Our own Milky Way is a barred spiral, a detail astronomers confirmed only in the early 2000s using infrared observations that could pierce through the dust obscuring the galactic center. Barred spirals are actually more common than pure spirals. Roughly 2/3 of all spiral galaxies in the nearby universe show some degree of central barring, making them the dominant disk galaxy type overall. Elliptical galaxies. Where spirals are flat and structured, ellipticals are smooth, featureless, and three-dimensional. More like flattened spheres than disks. They range enormously in size. Some are compact dwarfs, while others, like M87 in the Virgo cluster, are among the largest galaxies known, containing trillions of stars and spanning hundreds of thousands of light-years. Elliptical galaxies are dominated by old red stars. Their gas and dust have largely been used up or expelled, leaving little raw material for new star formation. Most formed early in cosmic history, either through rapid collapse of massive gas clouds or through repeated mergers of smaller galaxies. They are most commonly found at the centers of large galaxy clusters, where gravitational interactions have been most intense over billions of years. Lenticular galaxies. They occupy a middle ground between spirals and ellipticals, disc-shaped like a spiral, but without the defining arms, and aging like an elliptical. They have a central bulge and a smooth outer disk, but no organized spiral structure and very little ongoing star formation. The gas that once fueled new stars has either been consumed or stripped away. NGC 5866, seen nearly edge-on from Earth, is one of the clearest examples. A thin disk with a faint dust lane running through its center. How lenticulars came to be is still debated. Some may be former spirals, whose arms faded as star formation ceased. Others may have formed through galaxy mergers. They are particularly common in dense galaxy clusters, which suggests that the environment itself, close encounters, ram pressure stripping by hot cluster gas, plays a significant role in reshaping them. Irregular galaxies. They follow no clear pattern. No symmetric disk, no organized arms, no smooth elliptical form. Just chaotic arrangements of stars, gas, and dust that resist easy classification. Some are small and formless from birth, shaped by turbulent internal dynamics. Others were pulled out of shape by a gravitational encounter with a passing neighbor. The Large and Small Magellanic Clouds, two satellite galaxies of the Milky Way visible from the southern hemisphere, are among the most studied examples. Both are rich in gas and actively forming new stars, which gives them a patchy, uneven glow. Irregular galaxies tend to be smaller and less massive than spirals or ellipticals, but they often punch above their weight in star formation, making them bright relative to their size. Ring galaxies. They are one of the more dramatic shapes in the universe, a bright outer ring of star-forming regions surrounding a mostly empty interior with a small nucleus at the center. They do not form in isolation. The classic explanation is a cosmic bullseye collision. A smaller galaxy passes almost directly through the center of a larger disk galaxy. The impact sends a ripple of compressed gas and dust radiating outward, triggering a wave of star formation as it expands, like dropping a stone in still water. The Cartwheel Galaxy, located about 500 million light-years away, is the most famous example. Its outer ring spans roughly 150,000 light-years and is actively producing new stars at an exceptional rate. Ring galaxies are relatively rare, since they require a precise geometry of collision that does not happen often. Dwarf galaxies. They are the most numerous type of galaxy in the universe, yet they are easy to overlook. Small, faint, and low in mass, dwarf galaxies typically contain between a few million and a few billion stars, a fraction of the Milky Way's several hundred billion. They come in several forms: dwarf ellipticals, dwarf spirals, and dwarf irregulars. Many orbit larger galaxies as satellites. The Milky Way alone has dozens of known dwarf companions, including the Sagittarius dwarf spheroidal and the Canis Major dwarf. Some are ancient relics, nearly unchanged since the early universe. Others are actively forming stars. Dwarf galaxies play an important role in galaxy evolution. Over cosmic time, larger galaxies grow in part by absorbing and cannibalizing smaller ones, and dwarfs are the building blocks of that process. Peculiar galaxies. They are the outliers, galaxies that do not fit cleanly into any standard category. Their unusual shapes, distorted structures, or extreme features place them outside the conventional classification system. Most peculiar galaxies owe their appearance to interactions or collisions with other galaxies. The gravitational forces involved can stretch tidal tails of stars across hundreds of thousands of light-years, warp disks into warped S-curves, or trigger bursts of star formation so intense that the galaxy glows far brighter than normal. The antennae galaxies, two spirals in the process of merging, are a striking example. Their long, curving tails of stars extending away from the collision site like insect antennae. Peculiar galaxies remind astronomers that galaxy morphology is not fixed. Every galaxy has a history, and sometimes that history is written in a shape that defies simple description.